when I last left you, we were thinking about this recursive method count ats. The directions, the algorithm help told us to make sure that R and C are in bounds before checking to see if that position is an at symbol. If I put this check over on the left side of these R and C checks, I'm going to go out of bounds. At least if R or C is at one of the bordering rows or columns. Maybe we'll check that later. But you got to do the inbounds check first before getting the value at that position. So then we mark it as visited. You can put a V there, put a $sign there, put an X there, put a whatever you want to put there, asterisk, anything you want to. So now we bump up the count by 1 and make 4 recursive calls up, down, left, and right. When I do it, it's going to look so easy. It's going to look so much like Fibonacci, day 1 of recursion, and so much like all those fun and go calls we've been doing on worksheets. But when you try it, you know it's slightly painful. So here's our bump up by 1, return 1 plus, and now here comes all those recursive calls. One for up, 1 for down, 1 for left, and 1 for right. And that's it. Okay, so how do we go up? We go 1 row less, R minus 1, C. How do you go down? You go 1 row more, R plus 1, C. How do you go left? Same row, but 1 column to the left, 1 column less, C minus 1. How do you go right? Same row, but 1 column more, C plus 1. Let's compile and see if my typing's okay. Okay, that's good. Now let's test this stuff out. So what do you want to do? You want to call count ats using our at counter object A1. And give a position to start at. Let's do the top left corner, top left cell 0, 0. And there might not be an at symbol there, right? It might just be a dash. See if that compiles. That's good. Okay, so I'm going to show my original at counter. I'm going to count the ats and then show me my at counter after I've replaced all the visited cells with my V's. So in the top left corner of my first run, there was a dash. There were no ats. So I see 0 for 0 ats and no change to the matrix. Run it again. Same thing, no at in the top left. Third time through though, I do have an at in the top left corner. Including that at, how many ats are attached to it? And you'll count them 1, 2, 3, 4, 5, 6, 7, and that's why we see a 7. Plus, we see that we visited those at locations. Do you see the V's here in my output? That means it's working correctly. Okay. Now, again, if I put this check for out of bounds after I access the position, I should get an error message about half the time, I think. Let's see if that's true. Let's access my at symbol before checking for out of bounds. what I do, and okay. Okay, if there's no at there, we're not going to go out of bounds. But if there's an at there, I think we will. See what happens? I've got an at symbol up there. Look at the yellow highlight. Look at the red error messages. Okay, all over the place there's error messages because we're out of bounds. You've got to check to make sure you're in bounds first. Before accessing that position. It's a lot like you can't divide a numerator by a denominator unless you know the denominator is not a 0. Okay. So anyway, that's our at counter lab. Definitely one of my favorite short labs of the year. Just 3 little methods, and they are little, but boy, some tough concepts all over this lab.